Next one is to show you the flow through a clearance region, tip clearance. And that's also very critical. The showing a vortex, a flow being squeezed through to the clearance because of there's a gap. You cannot avoid it. Okay, if there's a large pressure gradient on one side versus other, the flow will squeeze out. When the flow squeezes out, how they behave, okay, you really need a good, accurate method to predict it, to understand it, and to improve it, right? Here is what you're seeing as rotor 37, many people know, and the flow near tip regions. And on your left-hand side chart is pressure distribution, and you can see there's a trace of clearance flow and the low pressure across the passage, right? And later on, you also see an interaction of the vortex flow with the shock flow, okay? And that is what's showing on the left-hand side. On your right-hand side, it's showing you the flow, once it gets through clearance, they push the incoming flow and roll them back, become a vortex, and going downstream interact with the blade behind. That kind of phenomena, the swirling flow, and I'll give you clear pictures. If we design it, if we enter this phenomena, well, one thing you will say, hey, what if we reduce the pressure difference, right? In that region, we can reduce clearance flow. That's what a lot of people try to do, is by doing bold design near tip. So that's really useful. If you can predict it, then you can design it to avoid the problem.